Hi all, this is a brief summary of the application we developed for the course of Image Processing 2012 under the guidance of Professor Sanjay Goyal. In this project, we are trying to generate the 3D model of an object using depth images captured using the Microsoft Kinect. Now Kinect has two cameras, one is for capturing the depth and one is for normal color video. We convert the depth map to a point cloud and map the color to each point of voxel. For this demo, we are modeling a CPU to showcase the 3D model generation. We need to capture all the faces of the object in a cyclic order to allow the stitching algorithm to do its job. Now we will show you how we rotate the object. So basically we capture the different faces of the object. For a cuboidal object such as this CPU, we need to capture the 4 basic faces on the sides. We are not considering the top and the bottom right now. So we capture all the faces on a keystroke one by one. Once we have rotated the object, we can simply capture the depth map to a separate file. And once we are done with that, we can show you how the 3D point cloud is generated. Once we capture the depth map and the color image, we convert the depth map to a point cloud of 640 by 480 spatial resolution and 128 depth resolution. Here you can see the combined output of the color image and the point cloud. There is a visible misalignment of the two. We align the color image to the point cloud before further processing. We can view this point cloud from any angle and study the depth of the captured scene, as you can clearly see in the video. Now we need to extract the object from its surroundings. This needs to be done algorithmically such that the system is independent of the object position and size. To do this, we created an algorithm based on the recursive flood filling concept. We assume that the point on the center of the screen belongs to the object of interest and then recursively find all neighboring points in 3D lying within a certain threshold of the depth. This gives us a set of points all belonging to the same 3D object. We trim the 3D point cloud using these dynamically calculated boundaries, and this gives us one face of the object of interest separated from its surroundings. This procedure is repeated for all the captured faces and the output is given to the stitching part. Now as you can see, all the 4 faces of the CPU have been successfully stitched together and we can view the 3D model from any angle. Since this is a cuboidal object, all the faces are at right angles to each other. But while capturing the depth map, we had kept the faces of the object perpendicular to the Kinect at all times and thus all the faces captured are parallel to each other. As we have captured the faces in cyclic order, we know the relative angle of each face to the previous one. When doing rotation in 3D, another issue is finding the axis of rotation. We did this by finding the median axis along the x, y and z direction, and the point cloud was rotated about these axes. Next we align the point clouds by the centroids and then translate the opposite faces to form the cuboidal object.